morning, everyone. Welcome to your virtual classroom. This is Mansi Bhosle, your mentor for physics and maths. Hope you had enjoyed my last class. I had introduced what a quadratic equation is, what do we mean by roots or the solutions of a quadratic equation. This class, we will be dealing with what are the different methods of solving a quadratic equation. The first and the foremost method that we'll discuss is factorization method, which is also called as splitting up the middle term. The second type of method is called as method of completing squares. And the third type of method is the quadratic formula method. So let's start. So let us start with the first and the most easiest way of solving a quadratic equation, that is splitting up the middle term. We have already studied this type of method in our lower grades, mostly normally in 7th or 8th grade. Splitting up the middle term method was taught to us, but in a very normal and a very non-complex way. Let's start. We know that ax square plus bx plus c equal to 0. This we call as the general term of a quadratic equation, right? So splitting up the middle terms says that a quadratic equation can have at the most, first of all, this is in general, any quadratic equation at the most it can have 2 zeros. Okay, so maximum number of zeros is 2. It can either have 2 zeros, it can either have 1 zero, or it can have no zeros, no real roots, we say that, or no zeros. Okay, so normally by splitting up the middle term, we consider that let the two zeros or the two roots of the quadratic formula be, one be alpha and let another be beta. So let alpha and beta be the two roots of the equation, right? So sum of these roots, sum, that is alpha plus beta, should be such so that it becomes equal to b. B is the coefficient of x, and the product of these roots, alpha into beta, should be equal to a into c. A is the coefficient of x square and c is the constant term, right? So whenever we take we have a quadratic equation and it says that solve or find the roots of the quadratic equation by the method of factorization, we have to take first the middle term b. We have to split it into two numbers such that the sum of the two numbers becomes equal to b and the product of those two numbers becomes equal to a into c. Let's take an example to solve this. 3x squared minus x minus 10 equal to 0. We need to solve this by the method of factorization. So now tell me, what will be b over here? So b is basically minus 1. A into c is 3 into minus 10, right? So this is minus 30. We need to split b in two terms wherein the sum of the two terms will be minus 1. So if we look at this, minus 30 is 5 6 are 30, and there is a difference of 1 in that. But if I say, can I write this minus 6 into 5, I'm going to get minus 30 over here. And again, if I do this, like minus 6 plus 5, so minus 6 plus 5 will again be giving me minus 1. So these are the two roots. So how will we go forward with this? See. So now this 3x squared minus x will be written as minus 6x plus 5x minus 10 equal to 0. Let these be the first two terms. This is the third and the fourth term. Take out the common values. So 3x x minus 2. Over here we can take out 5 as common. X minus 2 equal to 0. X minus 2 is the same term. Let's take the same term outside and put these two together. 3x plus 5 equal to 0. When I say this into this, there are two brackets which are equal to 0. So either this bracket is equal to 0 or this one is equal to 0. So therefore, we can write this as x minus 2 equal to 0 or 3x plus 5 equal to 0, right? So just transposing this x minus 2 over here, we can get two values of x. So x is equal to 2 or x is equal to minus 5 upon 3. We are just transposing these terms to the RHS. So these are the two roots of the given equation, or two zeros, or we can say two values of x, two solutions of x, which when we put up in this given polynomial, it will satisfy this equation, right? Example number 2, m square minus 14m plus 13 equal to 0. Tell me, how are we going to do this? First thing is to compare this with the general term ax square plus bx plus c. So according to that, your a becomes equal to 1, b becomes equal to minus 14, and c becomes equal to 13. So now the first thing that we have to do, that we have to split up b in two numbers such that the sum should be equal to a into c. Okay, so 14 should be split up in two numbers. I know a into c, 1 into 13 is going to be 13. 13 ones is 13, and 13 plus 1 is going to be 14. But we want minus 14 over here. So can I say that minus 13 and minus 1? Minus 13 minus 1, yes, it is minus 14. And if the product, if I say a into c 13, so like this can be equal to minus 30 minus 1, which is equal to plus 13. Okay, now let us solve this equation further. So now I can write m square minus 14m plus 13 equal to 0. I'm splitting this middle term. M square minus 13m minus 1m, I can just write it at minus m, plus 13 equal to 0. Okay, let's make terms of 2, and over here we'll take m as common, m minus 13. Over here nothing is common, so let's take minus 1 as common, so m minus 13. We'll keep a watch that this term and this term should be same. Okay, so now we will take this same term outside, m minus 13 and m minus 1 is equal to 0. So as we did the previous one, we know if the product is 0, either this term is going to be 0 or this term is going to be 0. So let's see, m minus 13 equal to 0 or m minus 1 equal to 0. So therefore, m is equal to 13 or m is equal to 1. So 13 and 1 are the solutions of the given quadratic equation, right? Let us do one more. Okay, I'll take this one. Nice one. Third, 3y square is equal to 15y. Now, if you observe, y is common over here. So can I just not, I mean, instead of splitting up the middle term and doing the entire thing, can I just cancel this y from both sides? So therefore, what will remain is 3y is equal to 15. So therefore, y is equal to 15 upon 3. So therefore, y is equal to 5. What the value of y? Okay. Secondly, let's take one more. This one. 6 root 3 x square plus 7x equal to root 3. Okay, understood the equation? 6 root 3. Coefficients can be in the form of root. Okay, there's no problem in that. So let me arrange this in the form of a general form. So this can be 6 root 3 x square plus 7x. I'll bring this root 3 to this side, transpose it to the LHS. This becomes minus root 3. It is equal to 0. Okay. Now, what is A? A is 6 root 3. What is C? C is minus root 3. So A into C, we have 6 root 3 into minus root 3. So root 3 into root 3, 3. So 6 into minus 3 is going to be minus 18. So A into C is minus 18. B over here is 7. So what is my target? My target is to split B in two terms so that the product becomes minus 18. I know that 18 is 9 twos are 18, but I want minus 2, right? So 9 minus 2. I know 9 minus 2 or minus 2 sum minus 2 plus 9 is going to give me plus 7. Okay, so now let's solve this. So we will expand this. Yes, we have taken the roots. It is, you can say, plus 9 minus 2. So let's take this as minus 2x plus 9x minus root 3 equal to 0. These are the first two terms. These are the third and the fourth term. So over here, if I say 2, can I take the entire 2x common? Yes, we can take. Over here, 3 root 3x will remain, and over here, minus 1 will remain. From here, let's take root 3 as common, because we know 9 is a multiple of 3. So 3 3s are, and if I take, what is 3? 3 into 3 is root 3 into root 3. So when I take root 3 outside, I am going to have 3 root 3 inside. Minus 1 again equal to 0. Okay. Now this term same, so we'll make it together. 3 root 3x minus 1 in one bracket, and 2x plus root 3 equal to 0 in another bracket. This is equal to 0 or this is equal to 0. So therefore 3 root 3x minus 1 equal to 0, or 2x plus root 3 is equal to 0, right? So x can be equal to 1 upon 3 root 3, or x is equal to minus root 3 upon 2. So these are the two, you can say, zeros or roots or solutions for that matter of the given quadratic equation. Understood? Okay. Now let's move on to the next type of method, that is called as completing the square. Completing square methods, again, we have to start with the general equation ax square plus bx plus c equal to 0. Okay. Now in this particular method, there are a series of steps that we have to follow, and we will directly come down to our roots or zeros of the given quadratic, right? So as far as the first step is concerned, first step says, we can see that here we have a general equation. Now this is your a. Okay, a is the coefficient of x square. So the very first step says that we need to divide the entire quadratic equation by a. Okay, so step 1 says divide the equation. Okay, divide the equation by a. So if I divide the equation by a, what am I going to get? This will get converted to x square plus b upon ax plus c upon a equal to 0. Okay. Next particular step, step 2. So we have arrived over here after having the step 1. Step 2 says add. So what is over here? So we have basically b upon a as coefficient of x. Okay, so next term says that we need to add and subtract. Okay, b upon 2a whole square. Add and subtract b upon 2a whole square. When we do this, what is going to happen? Let's see. So x square plus b by ax plus b upon 2a whole square minus b upon 2a whole square plus c upon a equal to 0. Right? Now, if you observe the first three terms of this equation, the first three terms are basically in the form of an identity, that is a square plus 2ab plus b square. And we know this identity is equal to a plus b whole square, right? So a plus b whole square. So now in this case, when we take these three terms, in this case, your a is equal to 1 and b is equal to b upon 2a. So the middle term, that was 2ab, basically that came into 2 into 1 into b upon 2a. So 2 and 2 got cancelled, and what did we have? We have b by a, right? So 2 from here and 2 from here got cancelled, and what we have is b upon a, which is this. Okay, so let us convert these first three terms in the identity form. So apply, third step says apply the identity. Apply the identity. So when we apply the identity, what we get is from step 3 is this, that is x plus b upon 2a whole square minus b upon 2a whole square plus c upon a. Now if you observe these terms, these last two terms, these are your constant terms. So let us transpose this constant terms to RHS. I am just shifting this everything to RHS, and what I get after shifting this to RHS will be x plus b upon 2a whole square equal to, this minus will become plus b upon 2a whole square minus c upon a. So after this, you just need to solve the equation and find out the value of x. If you see over here, we need to take a square root, and after taking the square root, it will always be plus and minus. So you will understand this when we solve one of the examples. So let us solve example we have, let's take this x square plus 8x minus 48 equal to 0. Now if you observe, a is equal to 1, so that's why it doesn't matter if we multiply the entire equation by 1, it is going to be same. B is equal to 8 and C is equal to minus 48, right? Okay, so now first term is already done. It doesn't have any effect on the equation. Second was adding and subtracting. B square add and subtract b upon 2a whole square. Okay. So now if I take these values over here, I get to know, so b upon 2 into 1 whole square. So that is basically 8 by 2, and 8 by, what is 8 by 2? 8 by 2 is 4. 4 square is 16. So that means I have to add and subtract 16 from both sides. So let us try. So now this becomes x square plus 8x plus 16 minus 16 minus 48 equal to 0. Added and subtracted. Now again, if you observe the first three terms, what is the first three terms? It is in the form of a square plus 2ab plus b square, wherein your a is 1, b is 4 because 4 square, right? And if I have to say the middle term 2ab, so 2 into 1 into 4, that is 8, right? So we will generalize this first three terms as x plus 4 whole square, because this entire thing will be a plus b whole square, right? Minus 16 minus 48. So minus 16 minus 48 will become 48 plus 10, 58, 58 plus 6, 64. Minus 64 equal to 0. Now let us transpose this to other side. So this is x plus 4 whole square equal to 64, right? Now if you see, we have a square on the RHS side. So let us take taking square root from both sides. So this will be x plus 4. We know 64 is root of 8. But whenever we take a square root of any number, this always has to be plus minus 8. Right? Now we have two possibilities over here. Either your x plus 4 is equal to plus 8, or x plus 4 is equal to minus 8. So if it is equal to plus 8, it will be 8 minus 4. X will be equal to 4. If it is equal to minus 8, it will be minus 4 minus 8. X will be equal to minus 12. Right? So this way, in this way is basically called as completing the square methods for finding out the roots of a quadratic equation. Understood? Let's take one more example. 9y square minus 12y plus 2 equal to 0. First step, divide by 9. So what do we get? Y square minus 12y upon 9 plus 2 upon 9 equal to 0. Now this 12 upon 9, what does it become? It becomes y square minus 4 by 3y plus 2 by 9 equal to 0. So as we see, your a over here, what is a? A is equal to 1. B is equal to minus 4 by 3. And C is equal to 2 upon 9, right? Second step is to add B by 2A whole square, add and subtract basically. So add and subtract B upon 2A whole square. So now what B by A already we have, because we have already divided by A. So what do we need to add and subtract? So it will be 4, 2 into 3. whole square to both sides, right? Y square minus 4 by 3 y plus 4, 3 to the is 6 plus 4 by 6 whole square minus 4 by 6 whole square plus 2 upon 9 equal to 0. As far as these two constant terms are concerned, we will transpose them to your RHS. And as far as this term is concerned, if you look at it carefully, this is in the form of a square minus 2ab plus b square, right? So can we write this as a minus b whole square, wherein your a over here is y and b is 4 by 6. Okay, so let us put this in the identity form. That means we have completed the square. Okay, so in this way, this entire method of solving a quadratic is called as completing squares method. Okay, so now y minus 4 upon 6 whole square equal to, minus will become plus 4 by 6 minus 2 by 9. So now let us solve this. So basically this will be 2, this will be 3. Whole square will be 4 upon 9 minus 2 upon 9. What is 4 upon 9 minus 2 by 9? 4 upon 9 minus 2 by 9 is 9 denominators are same. So 4 minus 2 upon 9. So this will be 2 upon 9. So now what do we have? We have y minus 4 by 6 whole square is equal to 2 upon 9. Now we need to get rid of the square. So what do? We will take square root of both sides. So now taking square roots, we will have y minus 4 by 6 is equal to root 2 upon 3. Okay, and now one more very, very important thing. Whenever we take a square root, we always take it in the form of plus minus. Okay, so over here we will have two possibilities. Y minus 4 by 6 is equal to plus root 2 by 3, or y minus 4 by 6 will be equal to minus root 2 upon 3. Okay, so now let's find out the two roots. So we have y 4 by 6. Now I can write it as 2 by 3. So minus will go that to this side. So I'm solving this first. So this will be 2 by 3 plus root 2 by 3. So this will be 2 plus root 2 upon 3. Now as far as this is concerned, this will be y minus 4 by 6 will go here and it will become plus 4 by 6. Okay, so let this be 2 by 3 minus root 2 by 3. So this will be 2 minus root 2 upon 3. So this is root 1. So these are your two roots of this equation, 9y square minus 12y plus 2 equal to 0, when we complete this or when we solve this by the method of completing the squares. The third type of method that we have for solving a quadratic equation is the quadratic formula method. As far as the quadratic formula method is concerned, I'll directly tell you the formula, wherein we just need to plug in the values of ABCs and find out the answers, or find out the roots basically. Now how this formula is derived, what is the formula? I'll tell you. X is the root, so x is equal to minus b plus minus under root b square minus 4ac the whole upon 2a. This is your quadratic formula. How this formula is derived, I'll share the link of my video in the comments below. Okay, because this is an entire, there's a big derivation behind this formula. Students who are interested to know how the formula is derived, they can refer that. Okay, so now we know the general formula, the general term of any quadratic equation is ax square plus bx plus c equal to 0. Find out the ABCs, just plug in the values or substitute the values of ABCs, A, B, C, simplify and get your answers. It's one of the most simple methods wherein you cannot go wrong unless and until your calculations are perfect. Okay, so let's take an example for this. Now I have, let's say, okay, I have an equation m square minus 14m plus 13 equal to 0. Compare this with your general term ax square plus bx plus c equal to 0. So a is equal to 1, b is equal to minus 14, and c is equal to 13. Okay, what is my quadratic formula? My quadratic formula is x is equal to minus b plus minus root b square minus 4ac whole upon 2a. Write the formula and make a box. Okay, so it will hammer up in your mind. Now substitute the ABCs. So therefore is equal to minus of minus 14 plus minus root b square. B is your minus 14, so like minus 14 square, 4, what is a is 1, c is 13, right? Entire thing upon 2 into 1. So minus into minus 14 will be plus 14 plus minus root 14. 14 is 196 minus 52 into whole upon 2. So this is basically 14 plus minus root 144, entire thing divided by 2. What is root 144? Root 144 is 12. So it will be 14 plus minus 12 whole upon 2. So now we need to split this plus minus. So now therefore x is equal to 14 plus 12 divided by 2, or x is equal to 14 minus 12 divided by 2, right? So that's equal to 26 divided by 2. So x is equal to 13, right? Now 14 minus 12, 14 minus 12 will be 2. So x is equal to 2 upon 2, x is equal to 1. So this is the way wherein we can solve the quadratic equation by the method of quadratic formula method. Simple. The quadratic formula method is this. Now there's one thing that I want to share to you regarding existence of roots. Okay, whether a given quadratic equation, the roots of the equation, will it exist or not? Okay, so now as far as the general term ax square plus bx plus c equal to 0, we know the degree being 2. What is degree? Degree is the highest power. Degree being 2, total number of roots can either be 2, it can be 1, or it can be 0. Okay, we know x is equal to minus b plus minus root b square minus 4ac whole upon 2a. Okay, now this term, which one? B square minus 4ac. B square minus 4ac is often called as discriminant. Okay, discriminant. Now this discriminant b square minus 4ac, it can be either greater than 0, it can be either equal to 0, or it can be less than 0. So there are these three possibilities. Whenever b square minus 4ac is greater than 0, so value can be like, for example, 20, 30, 64, anything which is greater than 0, we will have the roots will be real. That means it will be real numbers, and they will be distinct. Distinct means there will be two different roots. Okay, this is condition number 1. Condition number 2 states when b square minus 4ac is equal to 0. Okay, when the entire thing comes down to 0, again the roots will be real, but the roots will be same. Roots real and same. That means the same number will repeat itself twice. Okay, now the third condition goes if b square minus 4ac is less than 0. So that means it would be a negative number, and we know if b square minus let's see, minus 4ac less than 0. So less than 0 is a negative number, and we know this b square minus 4ac comes down in a root. Okay, so is there a root of negative number? Root of negative number is always an imaginary number. Okay, it is not a real number. So we just need to discard it. That means we can say that the given quadratic equation does not have real roots. Okay, so if b square minus 4ac is less than 0, simply say that the given quadratic equation has no real roots. Okay, you can say no real roots. Got that? Let us do some examples on this. So we know regarding the existence of roots, b square minus 4ac greater than 0, roots are real and distinct. Just the example that we saw wherein m was equal to 13 or m was equal to 1. So both the roots, they are real numbers, belong to real numbers, and they are different from each other. Okay. So now, when b square minus 4ac is equal to 0, so let's take an example. 25x square plus 30x plus 9 equal to 0. So when comparing them with the x square abc, so it's a is equal to 25, b is equal to 30, and c is equal to 9. So let's first find out the discriminant, b square minus 4ac. So that's 30 square minus, you can say 4 into 25 into 9. Which is, this is equal to 900. This 25 4s are 100, 100 9s are again 900. So 900 minus 900, this is 0. So now the roots of this particular equation will be real and it will be same. Real roots and same. So when you solve this particular equation by quadratic formula, the answers that you get is over here, x is equal to minus 3 by 5 and x is equal to minus 3 by 5. So real roots but same roots. B square minus 4ac is less than 0. So if it is less than 0, so let's take another example for that. So let's see, x square plus x plus 5 equal to 0. What is the discriminant? B square minus 4ac equal to 1 square minus 4 into 1 into 5. So this is 1, 5 4s are 20. It is equal to minus 19, right? So it's a negative number. It is less than 0. So the roots of this particular equation will not exist at all. No real roots. Because we know b square minus 4ac comes out in a root. So root of minus 19 is an imaginary number. Okay. Hope you understand all the three methods of solving a quadratic equation. Next, we have episode 3, wherein we will deal with relationship between roots of a quadratic and coefficients of a quadratic equation. Stay tuned. Hope you enjoyed the class. Thank you. Please do like, share, and subscribe my channel.